Welcome back, children. Today, class 9 Maths, chapter 2 Polynomials. So far we have finished up to 2.4, up to factor theorem. Okay. So now we are going to see algebraic identities. This is the next topic. So one more exercise is there, exercise 2.5. Okay. So there are some identities. I think up to 4 or 5 you already have studied in 8th standard, and just you recall all this, and some more identities are there. So up to 7 we will see in this class, and after 2-3 identities are there that we will see in the next class. Okay. So first just you put algebraic identities and you take all these 7 first in your classwork, and then now I will explain you first of all what is an identity. Okay. So what I am explaining here, that is for your understanding purpose. So this alone you take in your classwork. So now what is an identity? So algebraic identity means, identity means the word itself you can get the meaning. So identical you can find in the dictionary. Okay. Identical, that means same, and both sides same. So if you take this identity, this is equal sign, you see all having equal sign in the center. So left hand side, right hand side, and equal sign. So wherever you see equal sign, it is nothing but an equation. But here we are saying these are particular identities. You can easily by practice you can memorize this, and you can apply wherever we need it. And both sides they are identical. So only you are saying that this is identity, and singular is identity, and then IES instead of Y if you put, then you get identities plural. Okay. So algebraic identities, and for algebraic verb it defines that the unknowns. You see A, B. You see A, B. So the left hand side A, B, right hand side also A, B. So therefore what A, B means any two unknowns. You can take any letters, English alphabets, clear, to define the unknown. Sometimes X, Y we will take. You see here X introduced. You see here X, Y, Z they are introduced. So like that we can use the English alphabets to denote the unknowns. I already explained you when we start polynomial. So that is nothing but variables. Clear? So A, B, X, Y, Z, like that. Any unknowns we can use. In your book, you see for A and B, they have taken X and Y. So X plus Y whole square. So anyway, you can use the unknown. Okay. Now here these are the identities. So identities means what? For example, if you take the first one, I will explain you. A plus B the whole square is equal to A square plus B square plus 2AB. You see how I have written here? So this here A square plus 2AB and then plus B square. If you change this, then also it is correct. A square plus B square plus 2AB. Clear? So this B square is in the third part here. So if we change this order, then also correct, because everything is plus. So in the sign also you should observe carefully. That's all. So how we are saying that it is identity means both sides identical. If we substitute some values for A and B, both sides. Okay. For example, if you take A equal to 1, B equal to 2, then what happens? You see. Left hand side LHS A plus B whole square is there. Okay. So for A 1, for B 2, 1 plus 2 whole square. What is 1 plus 2? 3. So 3 square is 9. Okay. So this is the value 9 we got for the left hand side. If we substitute A equal to 1 and B equal to 2, and coming for the right hand side, you see separately left hand side, right hand side you are seeing. So A square plus B square plus 2AB. So for A 1, so you put 1 whole square. For b 2, you put 2 square plus 2 into 1 into 2. Okay, 2ab, that means what? 2 into a into b, together 2ab. So 2 into, for a put 1 and for b put 2. So that's what we have assumed. So now 1 square becomes 1 and 2 square becomes 4, and then 2 into 1 into 2, you get 4. So totally 9. So now the left hand side also 9, right hand side also 9. That means what? Both sides same, identical. So we are calling this as an identity. So unknowns are used, so it is called algebraic identity. Clear? So many identities are there. So algebraic identities. So here this session we see up to 7 and 3 more identities we will see in the next session. Clear? So just you take all these identities first. So this is for your understanding. So don't take what I am rubbing here. Okay. So this alone we put algebraic identities and you write all this. And now one by one we will read out the identities. The first one, a plus b whole square is equal to a square plus 2ab plus b square. So the order you may change. You can change and read. Okay, a square plus b square plus 2ab. That's no matter and no problem. Okay, and then a minus b whole square. You just see how I am reading. Okay, a minus b whole square equal to a square minus 2ab plus b square. So what's the change? Here plus, here minus. So here plus, here minus. AB term only the sign changes. Other two terms are same. A square and b square terms are same. Like that we can compare and analyze. So this is very important. Okay. Then only it will be easy to memorize. Next to the third one, a square minus b square equal to a plus b into a minus b. Sometimes we can write this as a minus b into a plus b. So both are same. 2 into 5, 5 into 2, both are same. So like that you can read. So a square minus b square equal to a plus b into a minus b. So between these two bracket there is what sign? Product, that is multiple sign. Okay, like that we have to understand. So a plus b into a minus b. And here fourth one, x plus a into x plus b equal to x square plus a plus b into x plus ab. So x square term, x term constant, like that. But for this identity, you see, in these two product, x, the first term same and the second term is different. Here a, here b. So these are the particular thing, notable thing. Clear? So for this identity, according to myself, I will tell you, you just know this, but while doing problems, no need to apply the same. If you just carry the usual multiplication, then also you will get the same answer and it will be also easy. Okay, comparing to this also. So whichever you find easy, you can choose. But I will explain you in both ways. Clear? So this identity alone I am telling you. If you want, you can apply this identity. Otherwise, directly we can do the usual multiplication. That's all. And fifth one, x plus y plus z whole square. You see, up to 4, you see the up to 3, 2 unknowns are used. Okay. Here you see x and then a, b. So anyhow 3, but 2, 2 like that. But here 3 unknowns in one side. So x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Clear? So all the last 3 terms you see, the coefficient is 2. So you can take common 2 and you can write 2 into x plus xy plus yz plus zx. That also correct. But in elaborate manner we have written here. And here a plus b whole cube. So far the exponent is 2, you see. Okay, wherever you see the highest power is 2. 2 only, but coming to 6 and 7 you see 3 is coming down. So a plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. Okay, a cube plus b cube, you see what is the power here? 3. So a cube b cube. What is the power here? Square. So a square b square comes. But here the power is 3. So here also 3 comes. Clear? So a cube plus b cube plus 3ab. Here 2ab. You got it. I think this is 3ab because the power is 3. So 3ab into a plus b. If you want, you can write this as, you see, a cube plus b cube plus, if you multiply with a, 3ab into a, you get 3a square b, and again 3ab into plus b. So plus 3ab square. Clear? And now coming to here, a minus b whole cube, both are same. Okay, don't get afraid, both are same. Just I am removing the bracket. Otherwise, if you want, you can read this, whichever is easy to you. And now a minus b whole cube is, you see, plus minus. So all the sign are plus in the right hand side, and you see all the sign minus in the right hand side when you put minus here. That's all. But if you remove the bracket, what happens? You see, a cube minus b cube minus 3ab into a minus 3a into a square. So 3a square b, and then minus into minus. What do you get? Plus 3ab into b. So b 2 times multiplied. So 3ab square b. So this is what we have to notice here. So here a cube minus b cube minus 3a square b, and the last term sign is plus when you remove the bracket. Otherwise minus only. But when you multiply minus 3ab with minus b, then you get minus into minus plus 3ab into b is 3ab square. So in these two, you see a square b and then a b square, the same thing, a square b, a b square, but the sign is different. Here all the signs are plus, but here the last term only plus when we remove the bracket. Otherwise, you see, in the first step only minus is there, but when we write in elaborate, that is expanding way, by removing the bracket, when you multiply, the last term becomes plus here. Other things are minus. So totally 4 terms. Clear? So you see here the variable, the power is 2. So how many terms? 1, 2, 3. Here the power is 3. So how many terms? 4 terms. 1, 2, 3, 4. But here it is in bracket. When you expand this, you get 4 terms. So as per the power, the terms will one more. So like that, you can understand this and compare and analyze this for easy memorization. Clear, children? And now coming to exercise 2.5. First option, x plus 4 into x plus 10. You see the first term of these two product is the same term, that is x, that is variable, okay, and these two are different. So which is applicable here? The fourth identity is applicable, but I am going to do applying this and also usual multiplication. You see what you get. So this is, you can apply identity x plus a into x plus b is equal to x square plus a plus b into x plus ab. If you use this identity, then this is solution. Okay, this we are finding solution. So this implies when we apply x plus 4, write the question. Okay, so you see, comparing the identity, x is same, but instead of a 4, instead of b 10. That's all. So you have to apply as it is, x square plus, instead of a you have to put 4 plus, instead of b 10, and then x is x only, so no problem. You see, x is x only. Okay, and then a b. So a into b means a is 4. With the bracket you write to avoid confusion. That's all. and you get x square plus 4 plus 10 is 14. So 14x plus 4 into 10 is 40. Clear, children? So the final answer is x square plus 14x plus 14. You see now another method, another way of doing. How to do this? X plus 4 into x plus 10. If you do usual multiplication, that means what? Here 2 terms, here 2 terms. So first you take and multiply with these 2, and then you take the second and multiply with these 2. You get the same thing. Okay. So x into x, what you get? X square, and then x into 10x. Clear or not? X into x, and then x into 10. So x into x square, and then x into 10x, and then you take the second term, and again you multiply the second bracket. Okay. So 4 into x. Can you understand what I am saying? Otherwise, one more step you have to write. If you know directly, you can do that. Otherwise, x into x plus 10 plus 4 into x plus 10. So this is what I drawn the mapping. Okay. So x into x square plus 10x plus 4x, 4x plus 4 into 10, 40. You see the simply, you get x square plus 14x plus 40. I think comparing to this is easy. So here there is a chance of error, because x here sometimes 2x instead of x. We will see one more sum. At the time you yourself feel whichever is easy. Clear? So this is the way of answering. Take it. Okay. So now coming to the next one. You see, children, here 3x plus 4 into 3x minus 5. So first term you see same, 3x. Only the difference is the second term. Here 4, here minus 5. So this is of the form fourth identity only. You see the first term of the two brackets are same, only the second term is different in two brackets. So we can use the fourth one, but if you use this identity, definitely you will do mistakes, because instead of x, here 3x. Clear? So here you have to put 3x the whole square, and here instead of x you should write 3x. Clear? So definitely most of the children are writing instead of x only, not what given here. So so that I am telling you, just you do the usual multiplication. So first 3x into 3x minus 5, and then plus 4 into 3x minus 1. So first term this bracket, second term this bracket. It will be quite easy comparing to the identity. Okay. So 3x into 3x, 9x square. 3 into 3, 9. X into x square. And then minus sign, because plus into minus you get minus. So 3x into 5. So first you should give importance to sign, and then the numerical, and then the variable. What? Sign, numerical, and then variable. Variable means unknowns. So this is the step what you have to focus. Okay, just for your knowledge I am writing that. So 9x square, and then 3x into minus 5 minus 3 into 5, 15, and x1 is there, so minus 15x. And coming to the next part, 4 into 3x, so plus sign only, 4 into 3, 12, x1. Clear? And now plus 4 into minus, minus 4 5s are 20, no variables is there. That's all. So now coming to the next step, 9x square, no x square term is there, only one term, 9x square. And then you see the right terms you can simplify, only the right terms you can add or subtract, in the lower classes, from lower classes itself we are doing that. So minus 15 plus 12. So which sign will come? Minus. Minus is the greater number. So minus, what is the difference of 15 and 12? 3. So minus 3x and then minus 20. That's all, children. So this is the answer for option 3. 9x square minus 3x minus 20. And then fifth sum, option 5. You see 3 minus 2x into 3 plus 2x. Okay. You see here, you can apply both way you can do this. Apply the identity also. Which identity? Fourth identity also applicable there. And you see that third identity, a plus b into a minus b. So left hand side is equal to right hand side. In the same way, right hand side is equal to left hand side. Am I right? So this is of the form third identity. So right side is there, so you have to write it left side. Clear? So you can take that solution part a minus b into a plus b equal to a square minus b square. Clear? So whichever is convenient we can apply, because the question is use suitable identities, that's all. So I am doing this. So instead of a 3, instead of b minus 2x. Clear? A minus b into a plus b. See, a minus b into a plus b. So now we can write 3 minus 2x into 3 plus 2x is nothing but, instead of a put 3 whole square minus, instead of b 2x. So 2x whole square. And what you get now, 3 square becomes 9 minus 2x the whole square. 2 square is 4 and then x term only. If you apply square, you get x square. So 4x square is the final answer. Hello children, in first sum, the rest of the options you take as homework. Clear? And now coming to question number 2, there are 3 options and I am going to do option 2 and option 3. Okay, option 1 you take as homework. You see 95 into 96, they are asking to evaluate, but you should not multiply the given two numbers directly. Okay, without multiplying directly, you have to use the simple form, that is identity, like that. So this we can write as, you see, 95 we can write as 100 minus 5 and 96 we can write as 100 minus 4. Am I right? So this is the simple form. 95 you can write as 100 minus 5, which is 95, and into, that is bracket. If you put bracket, that is multiple. So 100 minus 4 is nothing but 96. And you see here, this is you can apply the fourth identity. How I am saying is, the first terms of the two brackets are same, 100, 100, like that here x, and the a and b minus 5 minus 4 is there. So you have to take plus of minus 5 and plus of minus 4, then you treat that as a is minus 5 and b is minus 4. So what I told you, applying this fourth identity is somewhat difficult comparing in my to my way. Clear? So just to multiply as usual multiplication. So 100 into this you can put 100 minus 4, and then you see minus 5 is there, so directly we can put minus 5 into 100 minus 4. So this is nothing but what? 10,000. 100 into 100 minus 100 into 4, 400, and then minus 5 into 100 minus 500, and then minus into minus plus 5 into 4, 20. Is it clear to you? And now you see, this is 10,000 and 20. You can add the positive values. So 10,000, 20, and then two negative values are there, that is minus 400 and minus 500. So minus 900. Here, the usual subtraction. Okay, So 0 minus 0. So 0, 2 minus 0, 2, and 0 means we have to put 10, and this 0 becomes 9, and this 1 becomes 0. So 10 minus 9 is 1, and then 9. That's all. Clear? So 9120 is the value, the final value of 95 into 96. So this is the simple form. Clear? So without multiplying directly, you are using the simple form. I think this is better than applying this identity. So this is the identity applicable there, but I think so this is easy. Okay. So now coming to the next step, 104 into 96, option 3. So this we can write as 100 plus 4 into 100 minus 4. So look here, a plus b into a minus b, very easy. Okay, so a square minus b square, so 100 square minus 4 square, that's all. So which type is applicable? You can write in, put since a plus b into a minus b is equal to a square minus b square. So this identity is applicable here. So a 100 square minus b 4, so 4 square. So now 100 square is nothing but 10,000 minus 4 square is nothing but 16. Okay, so now 10,000 minus 16. So 10,000 minus 10 means what? Okay, so 9,990. So 16 means you should write 84. So 9,984 is the answer. And if you add 16, you will get 10,000. So this is the way of answering. And the first option is very easy. 103 into 107. So 100 plus 3 into 100 plus 7. So very easy. You can you do useful multiplication. Okay. Now coming to question number 3. First option is 9x square plus 6xy plus y square. So they are asking factorize it using appropriate identities. Okay. So how to factorize this? You see, appropriate means what? Whichever is applicable using the identity. Okay, we have to factorize. So factorize means what? I already told you. Giving in product, giving the answer in product form. That is called factorization. Okay, so, but this is not in that form, plus or between the terms. So if you write in a bracket, then it will be a product form. So that is called factorization. So we try that. So you see that 9x square, if you take square root, which is perfect square because 9 square number, x square means x into x, so square number. So here y square is y into y, so square number. So you can write this as, you see, the given question I am writing as 3x the whole square, okay, plus 6xy plus y the whole square. Can you understand? 9x square. So you have to observe whether the first term and the last term is a square terms. How you can say that it is perfect square? If it is multiplied same time, 2 times, same number 2 times. So x into x, 3 into 3. So they are square numbers, perfect square. So 9x square we can write as 3x the whole square because 3x into 3x is what? 9x square. So y into y is what? Y square. So just I am writing by changing this. And now you see, you can consider 3x as A, y as B. You can write here. A you consider as 3x and B you take as what? Y. Keeping in mind, you just write a square 3x the whole square. So plus sign is there, so plus 2ab. You see this identity. A square, b square is there. A square is 3x the whole square, b square is y the whole square. So instead of a 3x, instead of b y. So this is a square plus 2ab. 2 into what is a? 3x. And what is b? Y. and then plus y whole square. Now you see, I have splitted 6xy as 2 into 3x into y. Whereas, if you multiply, you get the same 6xy. 2 into 3, 6, x into xy, so 6xy. So, I am trying to get the form of the identity. So, the right side, a square plus 2ab plus b square. So, if you can write in this form, then you can write the left side form, a plus b whole square. So, here it is a square plus 2ab plus b square. So, a plus b, a 3x plus b is what? Y. 3x plus y whole square. You see how we have changed? Clear? So, this form to this form. Both are equal. But this is factorized form. So, you can write now this as 3x plus y into 3x plus y. So, often I am telling you, 10 means you can write as 2 into 5 or 5 into 2. Clear? So, that is the factorization, product form. We have given the answer in product form. This is called factorization. And coming to the next one, 4y square minus option 2, 4y square minus 4y plus 1. Yeah. So, you see, number 1 is also a square number because 1 into 1, 1. How many times? If you multiply, you get 1 only, but here we are taking per square. And 4y square is a square number, perfect square. We can write 4y square as 2y the whole square. Clear? So, just I am writing this as 2y the whole square minus 4y plus 1 whole square. So, instead of a, here 2y. So, instead of b, 1. You see how I am writing? So, now we can try for this identity because the middle term is negative, no? So, here negative means we try for this. So, a square, a is 2y, 2y whole square minus 2 into ab. Okay. For a, 2y. For b, 1. Again plus b square. So, 1 square. Is it clear? And now we can write a square minus 2ab plus b square. So, we can write the form a minus b whole square, that is 2y minus 1 the whole square, and this you can write as 2y minus 1 into 2y minus 1. That's the product form. Product of two binomials, you get this expression 4y square minus 4y plus 1. Clear, children? Third option is x square minus y square by 100. You see, just we can write this as x the whole square and this as y by 10 the whole square. Can you understand? Y square means square number. 100 is also a perfect square. So, y by 10 the whole square. So, this is converted to like this. And now, a square minus b square. It is of the form a square minus b square, which is equal to a plus b into a minus b. So, we can write that a plus b into a minus b. So, which identity is applicable here? Since we can write a square minus b square is equal to a plus b into a minus b. So, this identity is easily here. So, this is the answer. So, now we move to fourth one. Listen, children, question number 4. They are asking to expand this x plus 2y plus 4z whole square using suitable identity. Okay. So, this is of the form a plus b plus c whole square. Okay. If the variables in the question is x, y, z form, then we can take as a, b, c. We have to change because to avoid confusion, that's all. So, a plus b plus c whole square is nothing but a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So, in the beginning, in the identity, instead of abc, I wrote xyz. But here the question itself, the variables are x, y, z. So to avoid confusion, instead of x, y, z, a, b, c I have taken for identity. Clear? So a plus b plus c whole square is this much. So for this one, a means x, b 2y, c 4z. So like that you have to consider and you apply. So if you put straight to this equal sign, then it will occupy this space. Okay. So you just put here equal sign and you write what is a, x. So x square. Okay, and then for b 2y, so 2y whole square, and for c it is 4z, so 4z whole square plus 2ab. What? 2ab. So 2 into what is a, x, and what is b, 2y, and then plus 2bc. So plus, you just come the below line. Okay, but you have to leave some gap, not straight to the equal sign. Okay, so put plus here, and for 2bc, now we are here 2bc. So 2 into what is b? You see here b is 2y, and what is c? 4z. So like that, carefully you have to substitute. Plus 2ca plus 2 into ca. What is c? 4z. So 4z into, and what is a, x? So just we have to consider for a, x, for b 2y, for c 4z. That's all. So for a we have to put x. So finish it. And now you can just simplify. X the whole square is nothing but x square plus 2y the whole square is nothing but 4y square, and this is 4z whole square means 16z square, and plus 2 into 2 4xy. So I already told you have to follow this step: first sign and then numerical and then variable. So here everything is plus, so nothing problem will happen. So even though be careful. And plus 2 into 2 4 into 4 16, so 16yz, and then plus 2 into 4 8, that's all numerical, so 8zx. You see, so this is what you get. So x square plus 4y square plus 16z square plus 4xy plus 16yz plus 8zx. This is the expanded form of this question. Clear? So expanding by using the suitable identity. This is the question. And then coming to the option 5. Okay, option 5 I will do here. You see, minus 2x plus 5y minus 2x plus 5y minus 3z plus 5y minus 3z whole square. So it is given like this. What? Minus 2x plus 5y minus 3z whole square. So you have to expand using the same identity. So in solution part, you just take that identity a plus b plus c, the whole square is nothing but a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Clear? And now coming to the question. So this is implies minus 2x plus 5y minus 3z whole square. You put equal sign here. Clear? This is equal to a square. So minus 2x whole square. And then plus b square. So plus what is b? 5y. 5y whole square. Okay, plus c square. So what is c? Minus 3z. So see, minus sign is there, but here a plus b plus c, so everything plus in the identity. But if that is minus, you have to include minus sign also. Okay. So now plus c square means c, what is c? Minus 3z whole square. So a square plus b square plus c square over, and then 2ab plus 2 into what is a minus 2x. You have to see here minus 2x. Or what is b? 5y. So plus 5y. So put 5y. And then plus 2 bc. So come here. Plus 2 into what is b? 5y. Keep in mind what term we have to substitute. And then into c. What is c? Minus 3z. Plus 2ca. ca. What is c? Minus 3z. Okay. And then what is a here? Minus 2x. So like this you have to do. And then equal sign. Straight with that. And you simplify. Minus 2x whole square. So wherever you take square or minus, it will be plus. So no need to put plus. So 2 square is 4, x square. Minus square becomes plus. And then 2 square 4, x is x square when you take square. And then plus 5y square. 5y is 25. And then for y, if you apply square, you get 25y square. And then here plus. Because inside the bracket minus, if it applies square, you get plus. So 3 square is 9. For z, z square. So 9z square. Okay. And then here plus sign is there and here minus sign. So plus into minus, minus. You see how I am following the steps. First sign over and then number. 2 into 2, 4. 4 into 5, 20. You put 20 and then variable x, y. X into y. X, y. Clear? And now coming to this one. Plus. Sorry. You have to focus on sign first. Okay. You see? So plus is here and minus is here. So plus into minus. Clear? So minus sign will come. And then number 2 into 5, 10. 10 into 3, 30. Number finished. Now variable. Y into z, y, z. Clear? And now we come in here. Plus 2 into minus 3z into minus 2x. So plus. Okay. This is minus. This is also minus. So even number of times if you multiply minus what you get? Plus. So minus into minus plus. Already here plus. So totally plus sign. And then now number 2 into 3 6. 6 into 2 12. Number power. And then variable zx. So zx. Is it clear, children? So like that we have to expand using this identity for this question. Clear? First of all write the identity and write this question and equal to, you have to substitute a minus 2x, b 5y, c minus 3z, and you will get the final answer. And now coming to the option 5. So 6. We try that. Option 6. It's better to do it there. Fourth question, option 6. You see what is given there? 1 by 4 a. Fractions included. And then minus 1 by 2 b. And then plus 1 whole square. You see the square bracket is used here because fractions included. Okay, so the same identity we are going to apply there. So in the solution part, we just write a plus b plus c the whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Clear? And now just write the question. 1 by 4 a minus 1 by 2 b plus 1 the whole square. You put equal sign here. Often I am telling because this is identity simple one, but the question is somewhat big. So you have to write under that equal sign. You have to write under that question. Then you will have enough space here to write. Okay. So instead of a 1 by 4a, so a square means 1 by 4, sorry, a and then whole square. Here one thing I want to tell you, instead of a plus b plus c, you can take x plus y plus z. I think so, it is good to avoid confusion. Okay. I like to tell you before starting, x plus y plus z. Here x square, y square, z square, 2xy, 2yz and 2zx. Okay, this is that. So why? I told you, if it is AB like that, then you write the identity as XYZ. If there XYZ given, you take ABC to avoid confusion. That's all. So variable is not a matter. Okay. So now instead of x, 1 by 4a is here, and instead of y minus, we have to include minus because in the identity plus only there. So if minus comes, we have to include minus sign. So instead of y minus 1 by 2b, and then instead of z 1. So both are plus only, no? So instead of z we put 1. So x square over and plus y square. What is y? Minus 1 by 2b. So minus 1 by 2b the whole square. And then z square. What is that? 1. So plus 1 whole square. It is finished. Clear? And now plus 2xy. I am coming to the bottom line. So plus 2xy. 2 into what is x? That is 1 by 4a. So 1 by 4a. And what is y? Y is minus 1 by 2b. So minus 1 by 2b. So 2xy over. And coming to plus 2yz plus 2y. What is y? Minus 1 by 2b. So minus 1 by 2b. And what is z? That is 1. So put 1 here. And then last plus 2 zx. So plus 2 into what is that? 1. And what is x? Instead of x, 1 by 4a. So 1 by 4a. So like that we have to write clearly. Okay. Simple fraction only, but the same identity you have to use. Cap you should take. Okay. 1 by 4 and then a square. That means 1 by 4 means that is 1 into a will be. So a square in the numerator will come, and the denominator 4, if you take square 16. A square by 16, that's all. And then plus. You see, minus becomes plus when you take square. So plus 1b. And 1 is, if you take square, 1 only. So b square. 5. 2 is, if you take square, 4. And then plus 1 square is 1. Clear? 1 square becomes 1. And then plus into minus. So here minus sign is there. You see, minus sign is there. There plus sign. So plus into minus, minus. Clear? So minus sign will come. And then number you see 2 into 1 by 4 into 1 by 2. So like that we have to take. I am writing here 2 into 1 by 4 into 1 by 2. The sign I have put already. Plus into minus, minus. So number if you take 2 into 1 by 4 into 1 by 2. So this 2 gets cancelled. Numerator 2, denominator 2. Clear? So what the remaining? 1 by 4. So you just write 1 by 4 and then variable is a into b, ab, that's all. So ab. Clear or not? So like that we have to write. And then here you see plus into minus. So minus sign, you better write here minus 2 into 2. Here directly you can cancel. Here also you can cancel directly. Okay. So AB by 4 like that also you can write. So here minus B, that's all. Minus B alone is there. You see 1 into 1, 1. So B alone is there. And then the last one you see plus 1. So here this 2 and this denominator 4 you can simplify. Okay, like this. So a by 2, that's all. Minus a by 2. So in the last step we can write as a square by 16 plus b square by 4 plus 1 minus ab by 4. Clear? And then minus b. This is plus a by 2. That's all. So this is the final answer of this one. So now question number 5, factorize. So this is also factorize. So you have to give the answer in product form. You see, by observing the question, the first 3 terms itself, we come to understand that it is of the form this identity. So the right to left or either left to right, both are same. But the left side is given, so you have to write the right side. Clear? So a square plus b square plus c square. You see square term square like that. So here the mixing 2ab means it is mixed like that. So you have to check whether it is of the form the identity. Then only we can write the right side form, and then we can easily split into 2. If you got like this, then you can write as a plus b plus c into a plus b plus c. That's all product form. That is called factorization. Clear, children? So for that, so some key points I will give you. Second option I am doing for you, and first option is common, which is simple one. But this is the root symbol are there, so I am doing for you. You see, listen carefully this one. The first 3 terms itself, you see x square, y square, z square. Easily we can put x the whole square, y square is y the whole square, z square is z the whole square. So that is in square form. But what about the numbers? You see 2, 8, here 1, no problem, because the coefficient of y square is 1. So y the whole square, that's all. But here 2 and 8 are there. So you have to give a change for that. So 2 means you can write as root 2 the whole square. So which is nothing but 2. Root 2 into root 2 is nothing but 2. Okay. And 8 is here. So for 8 you can write as 4 into 2. And if you take square root of 8, then you get square root of 4 into 2. And root 4 is 2. And 2 root 2 you will get. For this 2, you have to put symbol, root symbol. So 2 root 2. Okay. So 2 root 2, if you take square, then you get 8. Clear? If you take square root of 8, you get 2 root 2. And if you take the square for this 2 root 2, you will get 8 only. Clear? So 8 you can write in the form 2 root 2 whole square. Just we apply square for checking. If you apply square for 2, you get 4. And if you apply square for root 2, you get 2. So 4 into 2, 8. Clear? So like that, a change is needed here to solve this problem. And now coming to the question, 2x square is implies. I am writing 2x square plus y square plus 8z square minus 2 root 2 xy plus 4 root 2 yz minus 8xz. Okay, can you visible it? Is it visible? Okay, children. So 4 root 2 yz minus, just I have taken the question, and you see now instead of 2x square I am writing what? Instead of 2 I can write root 2 and then this x alone and then put whole square. So now 2x square I have written as root 2x the whole square. So x square we can write as x the whole square. So 2 root 2. So root 2x the whole square. Clear? And now plus this is y the whole square. And now 8z square. We can try it. Here we have to put equal sign, not implies. Clear? So the question alone we are writing and put equal sign here. And this question you have to you are going to factorize. Okay? And then this 8 means you can write 2 root 2. For 8 we can write 2 root 2 whole square, but z is there, so put z and then whole square. Clear? For 8 2 root 2 and then for z square z and then put whole square, then it will factor. And then minus 2 root 2 xy is there. You see now one point I am going to say here. This is xy term and this is xz term. Okay, but in the identity everywhere plus is there, but here minus, here one minus. You see, here is one minus and here is one minus. So we have to focus here. Xy term, xz term. So which is the repeating variable x? You see, listen carefully. Xy term, xz term only having minus. So in this xy and xz, which is repeating variable x? X, here also x, but y, z is different, but x. So two variables is repeating. Therefore, for x term we have to put minus. You see how I am putting minus here, how I am selected minus to put here, because in xy and xz only minus there. So the repeating variable is x. So we put minus here before the x term. Clear? So minus root 2x. Then also it will be correct, because if we take square for minus, plus only will give. So now according to that we can write. So here minus. Okay. Otherwise you can write as plus 2ab right there. So plus. Okay. You have to focus on the variable and you write as it is. 2ab, 2 into, what is a? Now this is a, this is b, this is c. Clear? What is inside the bracket? This is a square. So for a minus root 2x, remember. And for b, y. And for c, 2 root 2 z. Clear, children? And now you just apply 2ab. What is a? Minus root 2x. That's all. Minus root 2x, and then now you focus on here, automatically you will get this. Okay, and then b, what is b? B is y, that's all. Now you see here, you just apply plus into minus minus 2 into root 2 x into y, xy. It's coming correctly. And then coming here plus 4 root 2 yz is there. Okay, now you just try in the form 2bc. So 2, what is b? See, what is b? Y. You put y. And what is c? C is 2 root 2 z. 2 root 2 z. And you try to get the same thing, this term, yz term. 2 into 2, 4. 4 root 2 yz. It's coming correctly. 4 root 2 yz. And then again you put plus like this, plus 2ca. 2 into, what is c? This is c. 2 root 2 z. 2 root 2 z. And then a. What is a? You see here, minus root 2 x. Minus root 2 x. I mean, just to review, either you are getting minus 8 x z. Okay, plus into minus minus 2 into 2 4. Okay, 4, and then root 2 into root 2 2. So totally 8. 4 into 2 8, and then z x z. So xz or zx, both are same. X into z or z into x. So like that we have changed the given question in the identity form, and it is coming correctly. So you can easily apply it. So this one we have changed as we have written as 2 into a into b, and this is 2 into b into c, and this is 2 into c a. So like that everything is correct. After changing as identity form, this are correct only. So you can directly apply the identity a plus b plus c the whole square. Okay, implies and then equal only. This is the question which is equal to this one and which is equal to now what I am writing. And now instead of a minus root 2 x, and then for plus b means plus y, plus c 2 root 2 z the whole square. This is a plus b plus c whole square. Now easily we can write in product form, that is factor system, minus root 2 x plus y plus 2 root 2 z into the same thing, minus root 2 x plus y plus 2 root 2 z So this is the product form of the given question. Clear? So you just see minus 2 root 2 x plus y plus 2 root 2 z is the correct one. Clear, children? And the remaining sums we will see in the next session. Thank you, children, and worksheet you have to do accordingly. Thank you.